solutions of each and every question. Friends, here is the first question on the screen. Sulfide ore of the metals are usually concentrated by froth flotation process. But there are certain, sulfide containing ore, which there is a certain exceptions, and it's concentrated by chemical leaching. So which of the following cannot be concentrated by froth flotation process? Answer is argentite, means Ag2S. Argentite is the answer. And as we are knowing that actually all the metal sulfide can be concentrated by the froth flotation process, but gold and silver can be concentrated by leaching process, and that's why answer is argentite. Copper matte possess. Now we are knowing the copper matte, the formula is Cu2S plus FeS. Okay, so that we can just see that cuprous sulfide and iron sulfide has been found. So answer is on that base. What is the principle of the hydraulic washing for the concentrations of an ore? As we see the principle of the relative density, that is a textbook based answer. What will happen when alum is added in water? Very easy one. Alum coagulate the mud and unnecessary particle. That can be coagulation, and the dirt can be removed, water become purified. When copper pellets is roasted in excess of air, C2O plus SO2 is obtained. FeO is in the form of impurity, which can be removed, and the reductions of the copper oxide can be carried out. Cuprous oxide can be carried out. Which of the following, flux is used for the formation of slag? Which of the following flux is used for the formation of slag? Okay. Now we are knowing that iron oxide, that is basic, that gang particle, it is basic one. So the flux should be opposite, means acidic one. So it should be acidic, and that's why the slag obtained can be removed. FeSiO3 slag, it can be removed. Okay. The reactions that does not define, next MCQ, the reaction that does not define calcinations. Friends, you are knowing that calcination in which oxide and carbonate containing ore on heating converted into corresponding, whatever the water and whatever some can get that vaporized impurities are present, that can be removed, and we are getting, so first example is zinc carbonate, gives zinc oxide and carbon dioxide, so it is example of calcination. Second one, it's example of roasting, it is not calcination, sulfide converted into oxide. Third, again it is dolomite, again it is example of calcinations, and iron oxide dot XH2 on heating gives iron oxide plus XH2, that is anhydrous iron oxide, that is also example of calcination. So answer is B, that is B is not calcination. Next MCQ, when impurity silver is reacted with the dilute aqueous solutions of the NaCN when native, that to form the water soluble complex whose presence is necessary. So we are knowing that in the leaching process, in the first step, we are just making the compounds of gold and silver with a cyanide, means sodium cyanide and potassium cyanide, in presence of air or oxygen. So first step, oxygen is required. Second step, we are knowing zinc is required for reducing agent. So here in our case, answer is oxygen is there, cyanide process. How is zinc extracted from zinc blend? There are two steps. First is roasting, that first zinc sulfide converted into zinc oxide, and then after conversion of the zinc oxide, it can be converted by reduction with carbon. So the roasting and then reduction by the carbon, answer A is the correct answer. What is the function of carbon when react with zinc oxide? As we discussed here, when react with zinc oxide, it's behave like a reducing agent. As a reducing agent, it can be make the delta G value more negative. So answer is to make the delta G not negative. Ellingham diagrams at high temperature, which statement is correct? As we are knowing that in Ellingham diagram, as given the diagrams from the figure, you can identify very easily that such diagram in which you can see that this one is magnesium, this one is aluminium. After this certain temperature, like here it is 1400 degrees Celsius, like this. Now aluminium and magnesium both curves change. Aluminium is now it's below part, magnesium is above part. As we are knowing that in Ellingham, that main principle that the graph which is below, that can be reduced the above graph metals. So here up to this point at low temperature, magnesium can reduce the aluminum, but high temperature is given more than 1500 degrees Celsius. Now aluminum is at the below part, MG graph it is above part. Now aluminum can reduce the magnesium. So that because the answer is magnesium is reduced by aluminum, that is the answer. Which one behave as a reducing agent in the reaction of Cu2S with Cu2O? Which one behave as a reducing agent? Okay, reaction is Cu2S plus 2Cu2O gives 6Cu plus SO2. Now sulfur minus 2, sulfur plus 4, copper plus 1, copper 0. So which question asks the reducing agent means such kind of this that ion which can reducing agent means a reductions of other oxidation itself. Sulfur minus 2 to plus 4, so itself oxidize, and copper plus 1 to 0 reduce. So S minus 2 sulfide ion behave here as a reducing agent. What is the function of the graphite in Hall-Heroult method for the extraction of aluminum? That is the next MCQ. As we are knowing that graphite, it is used, that as a reducing agent, because 12-203, when the reactions we are writing in Hall-Heroult process, plus 3 carbon, that gives 4 aluminum plus 3 carbon dioxide. So that it is behave as a reducing agent. Okay. Which method of the refining is used for the metal like zinc and mercury having the low melting point? This is very easy textbook based MCQ. We can just knowing that the distillations is the method in which the metal which have the low melting point can easily be separated. The slag that is formed, here it is CaSiO3 slag, in which extraction of which metal CaSiO3 slag is formed. Okay, so we are knowing that in CaSiO3 slag, that means CaO must be impurity and SiO2 should be taken. So CaSiO3 is observed. That means there must be a CaCO3 which on decomposition gives CaO plus CO2 and that calcium oxide. And I think that you are now remembering that this one is used on the extraction of iron, Fe. So that iron is the answer. What are the impurities that are not removed during the thermal purification of copper? Again, very easy MCQ. On that thermal decomposition, noble metal cannot be removed, but they are gathered under the anode with look like a AgAuPt. These are the noble metal gathered under the anode, and it is known as anode mud. So silver, gold, and platinum. That's the answer. In which of the following chromium is present? You know that? So we can just say then ruby is consists of the impurity of chromium metal along with this aluminum oxide, that's the gemstone. So ruby is the answer. Sulfide ore can be reduced only after it's converted into, very easy. For any extraction of metal, sulfide ore can be converted into oxide, and then the reaction proceed, and then after reductions by converting to metal. So there is, we are knowing that 2Cu2S plus 3O2 gives 2Cu2O plus 2SO2. So sulfide ore converted into oxide. So answer is on that base oxide. Now one numerical is given. That is also easy, nothing to worry. 1 gram charcoal absorbs 100 ml, 0.5 molar acetic acid. So mole of acetic acid, mole of CH3COOH, okay, is equal to molarity into V is equal to, we can say 0.5 into 100 divided by 1000 because in liter. So we are getting 0.05 mole. So mole of acetic acid. Now after the absorption, mole of acetic acid, again MV, again value is given 0.49 multiplied by 100 divided by 1000. is equal to 0.049 mole. Okay, so we are getting the two value. One is 0.505, other is 0.049 mole. So after the adsorption, the remaining total mole. So total mole of acetic acid after adsorption is equal to 0.05 minus 0.049 is equal to 0.001 mole. Okay, now they have given that what will be the surface area consumed by charcoal per molecule. So surface area of charcoal, so absorbed molecules. So here we are making adsorbed molecule of acetic acid is equal to whatever the value we are getting here multiplied by Avogadro number 6.02 into 10⁻²23. So it will give 6.02 into 10⁻²20. Okay, so that much molecules we are obtained. Now the question asks surface area consumed by charcoal per molecule of acetic acid. So surface area consumed by charcoal per molecules of acetic acid, not mole, molecule of acetic acid is equal to, in question they have given 3.01 into 10⁻²2. Now whatever the answer here we got obtained, just put here 6.02 into 10⁻²20. It's very easy. And after making the solution or making the simplify, it's give 5 into 10⁻² minus 19 meter square. That's the answer. So this is the answer of the numerical. Okay. Now in the extraction of copper from its sulfide ore, the metal is finally obtained by the reductions of cuprous oxide with Cu2O plus Cu2S gives 6Cu plus SO2. Okay. Now Cu2S, cuprous oxide, Cu2S. Cu means copper plus 1. So it's a copper 1 sulfide. That is the answer. Okay. Which equation is true for Langmuir adsorption isotherm? As we are knowing that X by M is equal to AP upon 1 plus BP at low temperature or low, it's given the equation to the low pressure. So at low pressure, the value of BP is equal to 0. And that's why X upon M is equal to AP. Give the correct order of the coagulation value of the given electrolyte for the coagulation of 1 liter of arsenic sulfide salt. Okay. Now in this MCQ, we have to see that the coagulation power is, that inversely proportional to the charge. Okay. So coagulation inversely proportional to charge. Okay. Now in our case, Na2SO4, that is second number, plus 1, which is greater than BaCl2, that should be third one, which is greater than FeCl3, here it is plus 2, here it is plus 3, that's given, that in the statement it is 1. So this one is the correct 2, 3, 1. Okay. So that 2, 3, 1, D is the answer. Now one reaction is given, that is a water gas CO plus H2 converted into formaldehyde in presence of which catalyst? Answer is in presence of copper converted into formaldehyde. Which one gives the highest value of the flocculation? As you are knowing, the flocculation is directly proportional to the charge. Okay. directly proportional to charge. Higher the charge, higher the flocculation. So we are saying then our case, the options Pb lead plus 4 is highest charge one, so higher the flocculation. Which of the following act as anode in Hall-Héroult process? As we are seeing, the graphite is reacting or behaving like anode in Hall-Héroult process. Which of the following is not suitable for chemist options? It is multimolecular. No, friends, it is unimolecular. So answer A. That is the correct answer in given question. Name of the enzyme due to which the protein is converted into amino acid. Protein can be converted into amino acid in the presence of pepsin. So that enzyme pepsin, in the presence of pepsin, that hydrolysis process, protein converted into amino acid. Which substance prepare colloidal salt in water? So that here we can say starch, they are preparing the colloidal salt. Which of the following reactions is suitable to get the chlorine from seawater? Very easy, textbook based. 2Cl minus plus 2H2O gives 2OH minus plus H2 plus we are getting that Cl2. So that in our case B is the correct answer. So where it is obtain chlorine. Okay. So C-butane, this is a C-butane NaCl from which we are getting the chlorine. So which of the following reactions suitable to get chlorine gas? So answer B is correct one. Next MCQ, the biochemical reactions by using urease enzyme is very easy one here. Using the urease option, we can just say that hydrolysis of urea. Urease that makes the hydrolysis of urea. Which colloidal salt is not prepared by Brady-Char method? Answer is iron, because Brady-Char method it is used for the it is colloidal salts of the some noble metal, gold, silver, and platinum. So iron is not suitable for that method. In which condition the rate of physisorptions increase? Rate of physisorptions inversely proportional to temperature. So low temperature make the rate of physisorptions increase. Primary test of the check the salt is colloidal or not is to make use of Tyndall effect. It's the best one to check the whether the salt is colloidal or not. How many of the following ore can be converted into its oxide by roasting? So 7 ore is given out of 7. Alumina, that cannot be, it is a one kind of aluminum oxide, okay, and that cannot be converted because it is already in oxide. Roasting is sulfide ore converted into oxide, here it is oxide. And other one is calamine, zinc carbonate, it is also not sulfide ore, so both of them cannot be converted into for both of these cases roasting is not applicable. So only 5 is the correct answer. Okay. Which of the following characteristics is associated with adsorption? This is also a very easy MCQ. During the adsorptions, that we can just see that somehow the exothermic process has been found, and exothermic process, so releasing the energy, so entropy decreasing, okay. So value of the delta H, delta S, and delta G all are -1. Correct order of the coagulating power, NaCl 52. Then gives BaCl to 0.96, and final is given MgSO4 0.33. Now load the value. Just remember the coagulation power is inversely proportional, that coagulation value. So coagulation value low, coagulation power is high. So MgSO4 is highest, and then BaCl2, and then NaCl. Okay, so that MgCl2, that is in our case 3, then 2, then 1. So 3, 2, 1, that is answer D is correct answer. Okay. Which are the following illustrations of homogeneous catalyst? So we can see the homogeneous means catalysis in which the catalyst and the remaining part, that means catalyst and all other reactant and products are in same phase, means same state. So here we can see that methyl acetate, we can just see that. So hydrolysis of methyl acetate in presence of acid, CS3, COOH. Hydrolysis, presence of H2SO4 gives acid and alcohol. So these are also same phase. So it is homogeneous catalysis. So lessons of homogeneous catalysis. Method following. Very easy. Different method is given and which elements or which metal can be matched with that one. First is cyanide method. As we are knowing, the cyanide method is for separation or concentrations of gold and silver. So that is leaching process. So answer gold. So A gives fourth. Second one is froth flotation process for sulfide ore. So any of the sulfide ore except gold and silver can be separated. So here it is zinc sulfide. So B is 2. Third one, it is the electrolysis reactions, aluminium. So third one is aluminium. And for zone refining, that is D. So zircon, we can say there is some germanium and silicon, germanium. These are these metalloids can be. So that is 1. So this is the correct answer. A4, B2, C3, D1. Answer is A. Which phenomena take place in chromatography? It's a absorptions based on the principle of absorptions. Answer is A. Goal number of hemoglobin is 0.03. Okay, this is one more numerical. Goal number of hemoglobin is 0.03. Hemoglobin, it's 0.03. Okay. Now, the question given, how much hemoglobin required for 100 ml gold salt? Okay. So that this gold salt can't be coagulated by 10 ml 10% NaCl. Okay. So for the prevention of 10 ml of gold, it is given that prevention of 10 ml of the gold salt require hemoglobin is equal to 0.03. So for 10 ml, very easy, 10 ml, 0.03 hemoglobin required. So for 100 ml, how much? Is equal to 100 multiplied by 0.03 divided by 10 is equal to 0.3 milligram. So answer is 0.3 milligram. That is 0.30. C is answer. Which one is showing lyophobic nature? As we can see that lyophobic water repellent. So sulfur is lyophobic one. Okay. So answer is sulfur. Okay, next MCQ. Colloidal solutions indicate, it's a very easy, low colloidal solutions. We can make it this, none of these high osmotic pressures, zero osmotic pressure, it is saying low osmotic pressures. Answer that's a low osmotic pressure. When missile form, so you know that we can say that above the value of CMC, critical missile concentration, and TK, that is a critical temperature. So that answer is B is correct one, where we can just make that above the value of CMC and TK. In which of the following reactions heterogeneous catalyst is involved? So we can see the heterogeneous means not in the same phase. So second and third, we can see that reactant is gaseous, product gaseous, catalyst in solid one. Reactant gases, product gases, catalyst in solid one. So answer is on that base 2 and 3. Okay. Which of the following is an example of absorptions? It is very easy. We can say that water on calcium chloride. So water is completely absorbed on the calcium chloride. So answer is D. Which of the following is interface cannot be, in which of the following interference cannot be obtained? Very easy, gas, in which gaseous, one gas mixed with another gas, totally miscible. So we cannot be separate the both of them surface. So answer is gas. So friends, I think that this solution will helpful to just rectify where you just make the mistake. And getting the good marks. And I hope that this solution will help you again in the next coming test for making good marks. Thank you.